Now, using a circular linked list, they are saying that they are no. This question is asked in GATE. I think 2000. 1 second. This question is asked in GATE 2004. Okay, so they are saying that using a circular linked list like this one, they are trying to implement the queue, and this one is the first node of the queue. First means front means the first node of the queue, and this one is the last node of the queue. Okay, and now they are saying that what no a single variable p is used to access the queue. Generally we need two variables, right, to access a queue, but then here they are saying that they are only using a single variable p. Then the question is, which node should p point to such that operations nq and dq can be performed in a constant time, which means now this p, this particular variable p, where should it point to, so that you can nq means you can add an element into the queue, and dq means delete an element from the queue in a constant time, which means you should not traverse the entire queue in order to add an element or delete an element. Then what is that where should you make the p point to? Then the options are a, rare node means here. So if you point here, will you be able to implement nq and dq in constant time? Or front node means here. The C option is not possible. They are saying that it is not possible with one variable. And D is next to the front node, which means this one. So if you observe it, we can perform nq and dq. See, whenever we want to perform an nq, which means add an element in a queue, where should we add it? After the rare element, isn't it? At the end. And whenever we want to delete an element, where should we want to delete? We should delete the element in the queue from the front, right? So now if p points here, it is very easy to implement these operations in a linear time. The reason is, if p points here, right, and now if you want to enter a new element, then what I will do is I'll create a new node, okay, and then I'll make that new node point to the front, which means I'll see that it points to the front, okay, and then I'll see the last node point to this, and now I'll make p point to this, which means I'll make p always point to the recently added element. So adding is just a constant time, nq, right? Now the rare will become not this one, rare will become this one, isn't it? And if I want to delete dq an element, then I have to delete it from the front. How can I delete it from the front? I have to just delete the one which is pointed by this. So I can delete this, which means I will use a temporary variable. I'll point to this, and then I'll make this one point to whatever this one is pointing to, which means I'll make this one point to this, right, and then I'll free this up. So if p is pointing to rare, then I can nq and dq in constant time. Now whenever you delete an element, then the remaining element will become the front node, right? So it doesn't matter much. So anyway, we can nq and dq elements in constant time if I point to the rare. How? While adding an element, just add it after this node and make it point to the front node, right? And also see that this p is incremented so that it will point to the newly added node. And while deleting this node and while deleting dq, right, we have to delete this one, which means this is already being pointed by the last node. You can directly delete it, free it, right? So in order to nq and dq, if p points to the rare node, it is very simple, right? So we can nq and dq in constant time in case if p points to the rare node. But if it points to the front node, right, it is difficult to nq and dq. The reason is, in order to nq, we have to go till the end. There is only one way, right? So you cannot go backwards. So you have to cross all the elements and add it at the end. In order to nq, in order to dq means I have to delete the same node, right? And deleting the same node can be done in constant time. In this case, how? You can copy all the elements here, and then you can delete this one. That is okay, but then adding an element is going to take order of n time. So pointing it at the end is better. See, why do you think that with just one variable we are able to achieve this feat? Because even though it is one variable which is pointing to the rare, from rare I can get the front in constant time, therefore it is working. Otherwise it wouldn't have worked. In case if it is not a circular linked list, it will never work. The reason is, one has to point to the front and other has to point to the rare. I didn't show you the implementation of a queue using single linked list. if you're trying to implement it, we should definitely have two variables. One variable should point to the front and other variable should point to the rear. In case of circular linked list, it is it is easy and it is better because this last node which was null in the single linked list is now used to store the pointer to the front node. Because of this advantage, we need only one variable to point, and we can perform only using one variable, either insertion or deletion. And only cases that you might have to handle is whenever there is only one element, right, and whenever there are zero elements. You have to handle them carefully. Okay, so anyway, those can be done, all the operations can be done using one pointer. So answer is this, right? Okay.